Chapter Physics, Chapter 28, Theory Video 2. The electron volt is what we are going to discuss about. Now, the photon is an extremely, it contains extremely small amount of energy, very much less than joule. So it is not going to be a very suitable. It is not a quite suitable unit to measure the energy of a photon. So then, instead of this, we use another energy unit, that is the electron volt. So electron volt is something that we have earlier learned to be used for used to measure energies which are very much lesser than a joule. In chapter 15 we discussed it. So when an electron travels through a potential difference, energy is transferred. If an electron which has a charge of 1.6 into 10 to the power minus 19 coulombs travels through a potential difference of 1 volt, the energy that changes would be given by W equals QV. That is going to be 1.6, charge is 1.6 into 10 to the power minus 19, volt is 1, so that is 1.6 into 10 to the power minus 19 joules, and that is the amount of energy that we refer to as an electron volt. So 1 electron volt is the energy gained by one single electron traveling through a potential difference of 1 volt. So we have 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. So when we know that when an electron passes through 1 volt, 1 electron volt of energy is gained or transferred to the electron. When 1 electron moves through 2 volts, 2 electron volts of energy is gained, and so on, right? So when 5 electrons move through 10 volts, then the total 5 electrons, 10 volts, total of 50 electron volts is transferred. So then to convert from electron volt to joule, we multiply by 1.6 into 10 to the power 19. To convert from joule to electron volt, we divide by 1.6 into 10 to the power minus 19. That is basic mathematics. Before we do the 5, 6, 7 questions, let's write a note about that. Write down electron volt. Because volt is too large a unit to be considered when talking about a single photon, we use electron volt as a more suitable quantity. Leave a line and write 1 electron volt is the amount of energy transferred to an electron or gained by an electron when an electron of charge 1.6 into 10 to the power minus 19 coulombs travel through a potential difference of 1 volt. So as a result, energy change W would be W equals QV, 1.6 into 10 to the power minus 19 into 1, which is going to be 1.60 into 10 to the power minus 19 joules. Therefore, 1 electron volt equals 1.60 into 10 to the power minus 19 joules. Leave a line and write. When 1 electron moves through 1 volts, 1 electron volt of energy is gained. When 1 electron moves through 2 volts, 2 electron volts of energy is gained. When 5 electrons move through 10 volts, a total of 50 electron volts is transferred, etc. Then leave a line, put a sign, write down. To convert from electron volt to joule, multiply by 1.6 into 10 to the power minus 19. to convert from joule to electron volts, divide by 1.6 into 10 to the power minus 19. So now I would suggest that you do question number 5, 6, 7. If you have any difficulties, tell me. So then when a charged particle is accelerated through a potential difference V, its kinetic energy also increases. So if we are talking about a single electron, and if it is accelerated from rest, we say EV equals half mv squared. EV equals half mv squared. So this is not actually this is not actually used for situations where charged particle is accelerated through a large voltage to speeds closer to speed of light, right? So that will actually theory of relativity will also come into this effect. So we have to take the relativistic effects into consideration, because the mass of a particle would increase when its speed get closer to speed of light. So this is less than that. So then we get we rearrange the electron speed. Then the velocity becomes, velocity is equal to the root of 2ev upon m. So any type of charged particles, including protons and ions, whatever it is, we can use this equation. Leave a line and write after doing the questions. After doing up to question number 7, write this down. When a charged particle is accelerated through a potential difference V, kinetic energy increases for an electron. It would be EV equals half mv squared. From this we can get below equation for the speed of electron. Please write this down. V equals square root 2ev upon m. 2ev upon m. Right. I hope this makes sense. Then so these are all related questions. You need to know that. So here please identify the two V's separately. Capital V stands for the voltage, simple V is for the velocity of the electron. Now you would be able to do question number 8. Now I'm going to move into practical activity 28.1. Now we are going to estimate the Planck constant H. So what we do is we use LEDs of different colors. Now you know that LEDs allow only, it is a diode, therefore it allows only for current to pass through only in one direction. And you know, there is a minimum voltage or threshold voltage that should be applied for this current to pass through. So what we do is we use different colors, because different colors allow different or require different threshold voltages before they conduct and start giving out light. If it gives out red color, that are very low of energy. So there is a very low threshold of voltage to make it conduct. If it is light blue color, that is higher energy photons, it would need a higher threshold to make it conduct. So now when we conduct current through these LEDs, what is going to produce these photons? You know, the easiest way is to understand that one single electron passing through the diode would give us would be transferred to a single photon. So then we can write the energy transferred by electron is equal to energy of photon. So we have equations for these. Simply into voltage is equal, that is energy transferred by electron, is equal to energy of photon is hc upon lambda. So V is the threshold voltage of any LED. Then E and C are known, we know them. Measurements of V and lambda will allow us to calculate H. So what we need the voltage across the LED when it begins to conduct, that is the threshold voltage. Then lambda is the wavelength, that is wavelength of light emitted by the LED. We can use a diffraction grating, or if usually when the LEDs are manufactured, they give the wavelength of the manufacturer would give the wavelength of the LED. So if we use several colors or several LEDs of different colors, then we can V and lambda can be determined for each one, and if we draw V against half lambda, then the graph will pass through the origin, and a gradient of hc upon E would be given, and through this we can estimate H. So what happens is, this is the type of the circuit that we develop. So the gradient would be equal to hc upon E. From that we can figure out what H is. So then we will have to do this question number 9, but before that write down a note. To estimate Planck constant, to estimate the Planck constant H, we use LEDs which allow electricity only in one direction, and it requires a minimum voltage, within brackets the threshold voltage, before it allows a current to pass through. Differently colored LEDs would have different threshold values. Example, red has a very low threshold value of very low threshold voltage, whereas light blue would have high threshold voltage. When electricity passes through LED, the electrical energy of a single electron gets transferred to the energy of a single photon. As a result, we get the equation energy transferred by electron equals energy of photon, E capital V equals hc upon lambda. V, put a dash and write underneath that, V threshold voltage of LED. E and C are given or known. Lambda either found through diffraction grating or as quoted by the manufacturer. When these values are obtained for different LEDs of different colors, and if the V against lambda, V against 1 upon lambda graph is drawn, the graph would pass through the origin and would have a gradient hc upon E. hc upon E, which can be used to figure out H. Right. So I hope you have understood. Please try to do question number 9. If you have any difficulties, let me know. Then we will discuss. Now, before we move on to the next part, make sure that you try to understand each and every theory part in this one, because this is a more or less theory questions based topic. So this is the reason why more details are given to you, but all the details are given in the book itself is good enough. So please read it once or twice if you don't understand after listening to the video. But if you still don't understand, then let me know, then I will explain it a little bit more and in a different way. Now we are going to learn about the photoelectric effect. In photoelectric effect, what happens is light would shine on a metal surface, and that results in electrons being released from it. So the Greek word for light is photo. So the reason photoelectric is coming from that. The electrons that come from this part is known as photoelectrons. When light shines on a metal surface, electrons are released from it, and this phenomena is known as the photoelectric effect. And the electrons that are removed from the metal would be known as photoelectrons. So we can observe this photoelectric effect, and we are going to discuss that in the practical. So what we do is we shine light onto a negatively charged metal plate, and we would see that some of the electrons of the metal would get emitted. So what happens is, when light carries it is transferred in the form of a wave, and that energy gets transferred onto the surface, and that energy releases the electrons from the metals. Now there were situations because this was not something easy to and still it is not something easy to explain. So there is a threshold frequency of light that is required for this particular effect to take place. If it is less than that threshold value, then we cannot observe this effect. So what we do is we fix a clean zinc plate at the top of a gold leaf electroscope. So electroscope is given a negative charge, and then the leaf would deflect. When we shine electromagnetic radiation from a mercury discharge lamp, so that has a very high intensity light, and the zinc and the leaf would gradually begin to fall. Mercury lamp has the ability of releasing strong ultraviolet radiation. So when we charge the electroscope, there would be excess electrons. So this now earlier we charged the when we charge with something with electrons, that means the electrons are getting trapped in there. So what we do now is, by using the mercury lamp, what we do is we remove these electrons. So the electrons would go away or would be emitted, and as a result the charge would decrease. So as a result the gold leaf would fall. However, if you place a glass sheet in between, the glass sheet would block the ultraviolet radiation, but because the glass can absorb the ultraviolet radiation, so that after that is done, you would see that the gold leaf is not going to fall. The gold leaf is not going to fall. That is because the gold leaf is not affected by this light. So that means it has gone below the threshold value. So for it to be effective, it has to be above the threshold value. Write down a note. Photoelectric effect. When light is shown on a metal, electrons are removed from the metal plate. This release of electrons is known, due to light, is known as photoelectric effect. This can be observed using a gold leaf electroscope onto which a zinc plate is attached. When the electroscope is given a negative charge, the leaf will get deflected. However, when a mercury lamp is shown upon the zinc plate, the strong ultraviolet radiation of the light would make the electrons to leave, and as a result the charge of the electroscope will be lost and the gold leaf will fall. However, when a glass sheet is placed in between, it will absorb this ultraviolet radiation making the electrons to be not lost, proving that there is a threshold value to the strength of the light that makes the electrons to be removed. If the threshold frequency, if the I'm sorry, but please write it like this. If the light has gone below the threshold frequency, then photoelectric effect cannot be observed. If it helps, draw this figure 28.7. If you can understand, then no problem. We will, in the next video, we will go to the next, we will discuss threshold frequency and wavelength.